Hello guys, you are welcome to today's tutorial. In this tutorial, we are proceeding to look at some of the basic questions under mechanics. And so we have the first question here, which says that a particle is moving in a straight line with a velocity of 10 meters per second. So the velocity here is 10 meters per second when it is given an acceleration of, so velocity is equals to 10 meters per second, and then acceleration a, which is equals to -2 meters per second squared, and then the time t equals to 8 seconds. So when it is given an acceleration of this, draw a velocity time graph for the 8-second time interval, and use it to find the time when the direction of the motion or particle is reversed. Take note of this. So the motion or the direction of a particle will be reversed when the velocity becomes 0. That's why you should know. When the velocity becomes 0, then that is the only point that we can actually go back. Because when we hit 0 and we are proceeding, it means we are hitting negatives. And when velocity is negative, it means we are going in the opposite direction to the direction that we started with. So let's say if we're going here, it means we are now going here. So velocity being positive, we are going here. If it's negative, then we are going in the opposite direction. Okay, that's what you should know. Okay, so now they are saying that we should draw a velocity time graph. So I'm just trying to sketch something here, and then something like this. And so but the way this thing is, so we can have something like this will be our 0 line this time around, and then let's assume that we started here, our velocity of 10 meters per second, and so here is 0. Okay, and now let's assume that we have maybe our time, we have 2, 4, 6, 8 and 10. So let's assume that maybe here is probably, maybe let me put a negative, so this is maybe -2, -4, -6, and maybe -8 or something. So now we started here, our velocity, that's when time was 0. We started moving, a particle is moving in a straight line with a velocity of this, and so that's where we started at. And so if we hit 0, then we go in the reverse direction. So we are decelerating, so our this thing will come down. Let me use this. So our line come down like this, and maybe like this. Okay, so there will be, okay, so I can actually use the one of the equations of motion to get something from this. We know that V is equals to U plus AT, but here we will only go in the reverse direction if our final velocity is 0. Here our initial velocity is 10 and our acceleration is -2, and so we can predict the time. So if we substitute these things into this, have 0 to be equals to 10 plus a, which is -2 times t, and so we have -10 equals to -2t, -2, -2, this and this. Therefore t is equals to 5. So the car will go in a reverse direction if the time here is 5. So that will be at this point here. So this point here, and that is 5 here. So we have 5 seconds. When the time is 5 seconds, then we go in the reverse direction. And now that is the time we are looking for. Now they are saying that we should calculate the increase in displacement during the 8 seconds. So we know that the total time used there is 8. That's the time. That's why I drew this graph to this point. Okay, so the total time used there is 8, and then so it means if here is 5, then the remaining time left is 3, like this. And so, and then what will be the velocity? So how do we get the velocity for this place? So let's assume that we are using the same equation, which is v equals to u plus at, and we know that our a is -2 for the whole period. A is -2, and then the time this time around is the whole thing, which is the 8, and then our initial velocity u is equals to 10. And so let's see, that will just be v equals to the 10 plus -2 times 8. So we have 10 minus 16 is equals to -6 meters per second. So it means that we have this line. Actually, we're supposed to be here. So we will have this particular triangle here, like this. Okay, so now they are saying that we should the increase in displacement. So we will first have to calculate the displacement for the first part, which is this triangle here, this one here. So that area, let's see, the area for that triangle is half base. The base for that one is 5, because from here to coming here, the time over there is 5. So we have 5 times the height. The height is 10, and everything here is equals to 25. So that's 25 meters. And then the area for the triangle down here, so this area 1, now area 2 for the down triangle here, this one, that's when the base is 3. So we have half times 3 times the height, which is -6. And so everything here gives us -9. And so the displacement d equals to the two distances a1 plus a2 is equals to 25 minus 9, and that's equals to 16 meters. So this is the displacement for that part. And now they are asking us to find the total distance traveled in this time. We know that distance is in absolute, and so the total distance will just be the absolute values of the two. So distance equals to absolute of a1 plus absolute of a2, and this becomes 25 plus absolute of -9, and we have 34 meters. So this is the distance for that part. So we'll stop here and we'll continue with the next thing. Thank you for watching. Kindly subscribe.